Yeah. So in this intrusion prevention system, just give a second, please. Yeah. So in this intrusion prevention and intrusion detection devices, so the networking, architecture paradigm shift is required to defend against the fast moving and the evolving attacks. So this must include the cost effective uh, of your intrusion detection and the prevention systems, such as your IDS and your IDP, that is also required to protect your network by sensing the traffic which is coming inside the network and outside the network. So when the network architecture integrates these solutions, intrusion prevention and intrusion detection solutions, into the entry and exit point of your network. So let us consider this network. What is the entry point and what is the exit point of this network? In this case, in this small network, what is the entry point and what is the exit point? Yeah. So let me give the name of this system, like it is management system. Let me write the router 1, the router 2. So what is the entry point and what is the exit point for this network? R1 is, R2 is the entry point, and R1 is so as we are saying that the next generation firewalls, they include the intrusion detection and intrusion prevention system at the network entry point and exit point. So in this network, is it a private network or is it a networks of network? This architecture. Private. Any other points? This portion is private network, LAN 1. This is your LAN 2. So networks of networks connected through your internet. If you are finding this symbol cloudy, means it is a public network. So it is connecting two private networks through your internet. Right? So it is networks of your networks. So then this intrusion prevention and detection devices, these devices are placed at the entry and exit point of your network. As said, the entry point and exit point. So what is the exit point of this private network means? The exit point is this router. Suppose R1. What is the entry point for this network means? The entry point is from this public network, whatever is coming, that is the, suppose R2. So that is your intrusion prevention or detection system exists in between the exit and entry point. So where you are going to connect this intrusion prevention or detection system means the output port of your edge router of private network, not inside port, output port. So then how it is going to be work in this means when implementing this, the IDS or your IPS, intrusion detection system or prevention system, it is important to be familiar with the type of your systems available, what type of systems are available there, that we need to check it out in this case, and the host based and network based approaches. And third point is the placement of these systems, where we are placing is most important. So here you are saying it is a host based one, which is inside. When it is connecting to other networks, it is network based one. So the third part is where we are going to placing is another important part to implement this intrusion detection and prevention system. The placement and the role of the signature categories, what type of signatures should be used for sensing the data which is coming inside the network and going from the network to outside world. So in this, the basic characteristics of your IDS and IPS is the intrusion detection and your intrusion prevention system. If you see the common characteristics of IDS as well as the IPS, both the technologies are deployed as your sensors. It's both the technologies. So this is what the common properties of both of these. Then both technologies, IDS or IPS, they use the signatures to detect the pattern. Signatures to detect the pattern. So what do you mean by a signature for detecting the pattern? Any idea? Already? In general, signatures, no. Do you heard this terminology, signatures in the network? So in signatures, what it happens, suppose if we have any plain text, like, let me call, suppose Raj is one plain text. So this plain text is given as an input to a hash algorithm. Let me call this as, suppose, X. So a hash of X will be there. So whatever output comes from this hash function, we call that as your digest. So this digest is concatenated with this plain text Raj. Okay. So here the point is whatever the output of your hash is there, we call that as digest. This digest is encrypted, not this plain text. So how it is encrypted means your digest is encrypted with the private key of your sender using a private key. So it will encrypt, so it will give your ciphertext. Ciphertext will give. So then this part, the ciphertext part, is concatenated as the encrypted form of your digest with your concatenator. So this entire thing is known as your signature. So what is the use of this signature means this signature is verified by the intrusion detection system or your prevention system of going packet or coming packet. So whatever the traffic is there for outgoing traffic, suppose that entire traffic is considered as your plain text. Okay, so entire traffic means when it is going to bit stream, right? That entire bit stream captured and that will be considered as your plain text. That plain text applied to the hash function, the secure hash algorithms SHA 256, that depends which signature type you are using, whether SHA 256 or SHA-512, or whether you are using MD5 algorithm, whether you are using any other secure hash algorithm, that depends. So the signature type. So that plain text is given as an input to your hash algorithm. So hash algorithm generates a digest. That digest is encrypted with the private key of your sender. So it becomes the the encrypted form ciphertext of your digest that is concatenated with your plain text. When that packet is received by your end device, the same operation will done in a reverse process. That is means what? Whatever this signature is received, from that signature, the digest is separated and plain text is separated. So now again, this plain text is given as an input to the same hash function which is used at the sender side. So then from there you will get one digest here. So that digest, the hash value which is encrypted because your digest, that digest is matched with the received digest. If it is matching, that means the traffic which is coming from outside the network is accepted. That means same plain text are generating. Digest is matching means there is an integrity of traffic from inside network to your outside network and outside network to inside network. So based on this, if this signature is not matching, suppose, then these intrusion prevention system and detection systems or devices, they give alarm that whatever the traffic is received, it is a malicious traffic, be alert. So that is the common feature of these IDS as well as the IPS. Another common feature is the both can detect the atomic patterns, that is single packet, or the composite pattern means your multi packets. That means this detection can be happen for packet to packet, or group of packets can be clubbed together to generate the signature. Based on that signature, checks whether they are valid or not. So these are some common characteristics. So in this diagram, if you see the first step, let us consider this user is a malicious user. So the malicious traffic is sent from user 1 to the network. So this malicious traffic is sent to the target host that is inside the network. So then how this the packet is traveling through this network. First it goes to the public network. From that public network, based on the routing protocol path which is determined, it goes to this router 1, then it goes to this router 2, and then it will reach to your target. So during this process, when this malicious traffic is sent, when it is forwarded through your internet to your private network or towards your private network, the traffic is routed into the network and received by your intrusion prevention system. So what is the job of intrusion prevention system? It is deployed at the entry and exit point of your network, right? And the role of this one is they use the signatures to detect the patterns of your misuse in this network traffic. So upon receiving that the malicious traffic, this intrusion prevention system, that is the sensors, so when it is routed through this IPS sensor, where it is blocked, that if that malicious traffic is forwarded or injecting inside this network, means the signature of that traffic is not matched with the signature which is computed by this intrusion prevention system. When it is not matching, then automatically it will the invoker alert the inside the network that some malicious traffic is getting inside network. So this IPS enables the sensor and sends the logging information regarding that traffic to the network security management console of your router. The security management console, another system of your routers. So upon enabling this security management console regarding this traffic information, it also, the IPS enables the sensor that kills this traffic, and it is sent to the bit bucket. So upon detecting that traffic which is coming from the malicious node, that will be sensed by this IPS by checking the signature. If it is not matching, it do two important rule. One, it automatically enables this management console and kill that malicious traffic and send it to your bit bucket. Now here question is, why this management console is enabled by the IPS, intrusion prevention system. Console is nothing but one more port, right? So it enables, it alerts the router that through this particular port or Ethernet line, malicious traffic is coming. So don't accept this traffic further anymore. So any traffic coming through that console, that will simply drop at the entry level only. If the router unable to drop that at the entry level, that will inject into your private network and then start getting information of all the hosts inside the network. And once the host information like IP addresses and the what DNS servers that they are using, they can do any kind of malpractice. So that is the important point of your intrusion prevention system, which plays an important role inside and outside of your network. So this IDS and IPS technologies are both deployed as sensors. IDS are the IPS sensor, both deployed as your sensors, and this IDS or IPS sensors can be in the form of several different devices. So what are those devices? Let us see. The type of the IPS are a router configured with the IPS software, or so they can be configured at the router level, or this device is specially designed to provide the dedicated IPS or your IDS services. First one is, either you can configure at the router level, or you can have a special device and connect to your router at the outbound port here. Or third way is the network module that installed in an adaptive security application, that is having the separate devices, or they can configure inside the switch, that is your access level switches, or your distributor level switches, or your core level switches, or they can configure at the router partners. So these are three different ways of deploying these IPS sensors in a different architecture. So that depends. If it is a smaller network, suppose having with limited number of hosts inside, then instead of going and having a dedicated specially designed device, you simply go and configure at the switch level itself. Because if you have only 20 or 30 systems, suppose, if you are having some hundreds of systems, in that case you can configure at the router level. These services you can configure, you can enable these services. or if you have thousands and millions of the devices, then there you can have this specially designed intrusion prevention or detection system, because they works like, their computational power will be more, their sensing power will be more, because they are specially designed for that. So that depends upon the network. So these IDS and IPS technologies use these signatures to detect the patterns in network traffic, as we said. So a signature is a set of rules for this IPS and the IDS to detect malicious activities. As we said, the entire what you call the packet or traffic will be considered as your plain text, and that will generate the signature. So, what are the advantages and disadvantages of your IDS and the IPS in this network? So, for IDS solution, the advantages are the no impact on network, or the latency or jitter will be there in this case. And second advantage is by introducing these IDS devices, there is no network impact if there is a sensor failure. So there is no network impact means if the sensors fails also, your network still enabled and able to send the packets and able to receive the packets. If this IDS system, because these IDS are an additional interface connection at your router level. If they goes off also, it doesn't affect the network traffic, but the security issues comes into the picture. If they are not enabled, then there is a chance of your attackers to attack your network by sending some malicious traffic into your network. And then IDS, with this IDS, there is no network impact if there is no sensor overload. So these are the advantages. The same way with the intrusion prevention system also, they stops trigger packets. That is means they don't disturb the packets which are coming and going out. They just check whether the signatures are matching or not and try to alert the router management console. And they can use the stream normalization techniques. But disadvantage here is the IDS response action cannot stop trigger packets. That means if any packet is coming inside the network, if it is found that it is a malicious packet, so before releasing that packet inside the network, this signature computation will be done, matching will be done, after that it will release. Whereas prevention, it is just checking a copy of that. So still, it won't affect for that. So the correct returning required for the response action, so it is more, this IDS is the more vulnerable to detect the security aviation techniques. And whereas this IPS sensor issues the might affect the network traffic, it just alerts. So the sensors overloading impacts the network is another disadvantage of this IPS, and some impact on your network latency and the jitters also. So as we said, the deployment consideration of these devices, IDS or IPS technologies, can complete each other. They can complement each other, but deciding which implementation to use is based on the security goals, whether it is a host-based one or network-based one or the policy-based one. So which one it is used in to implement these IDS or IPS for any of the organizations at the state in their network security policies. So as we said, the types of your intrusion prevention system, there are two primary kind of IPS are there. One is your host based and your network based one. So what happens at the host based one, and what happens at the network based one. So in the host based network, when you are deploying this IPS at the host based means what? Host machines. If it is network based means the network devices included that, switches and your routers and other security devices. So in host based, the type of your IPS, or we simply call the HIPS also sometimes. This is a software which is installed on any of the hosts if it is connected to router which is connected with any other host, suppose the host 2 which is outside this network, then there will be a software that is installed on the host to monitor and analyze the suspicious activities. Any software that will be installed on this host. So what are the different tools are there for this intrusion prevention that we will see for the network traffic monitoring and analyzing. For example, throughout your lab you might have used the Wireshark tool. Why we are using the Wireshark tool? To analyze the traffic. In packet, what is the source address, what is the destination address, what is the timestamp of that. Another one is you can have the Nmap. So these are all the softwares which are used for monitoring the traffic at host level also. So your servers also comes under the host category. Your desktops, laptops, everything comes under your host category, right? So a significant disadvantage of this host-based the IPS, the intrusion prevention system, is that it can monitor and protect operating system. The OS protection will be there, and the critical system process like the RPS or something like that are specific to that host. But with the detailed knowledge of the operating system or the HIPS can monitor the abnormal activity of your network traffic that prevent the host from executing certain commands that do not match typical behavior here. So this suspicious or malicious behavior might include the unauthorized registry updated to your host level in this case. So that will allow some of the traffic inside the host. So this the network traffic can also be monitored to prevent the host from participating in the denial of your service. We call the DOS services by just following certain rules, because sometimes whatever the applications which we are installing, the software which we are installing, they may or may not be monitor the entire traffic securely. So this HIPS can be thought of as a combination of your antivirus softwares to protect it from some of the malwares or the anti-malware software on your firewall, but combined with the network-based IPS, the host-based IPS with your network-based IPS, that can give you the effective tool in providing the additional protection for any of the host. So that means some of the traffic will be monitored by the software, and most of the traffic will be monitored by your network-based IPS, which is configured at your switch level or at your router level. So the advantage and disadvantage of this HIPS is, as said, they provide protection specific to the host operating system. It's inside the operating system and providing some critical processes, as we're saying. They provide operating systems and application level protection only. and they protect the host after the message is decrypted. But disadvantage is operating system is depends. It is a dependent one. Which operating system you are using, and it must be the installed on all hosts. So if your network is having suppose n number of hosts in the network, which are all connected to a single switch, so you need to install this host based one on every system. That is another disadvantage. In that, some systems may have the Windows, some systems may have the Unix operating system. So different systems may have different operating system. For different operating systems, you need to install different software. So instead of that, if it is combined with the network-based one, so most of the traffic will be filtered here itself. So that is the network-based. As we said, in network-based IPS, there is a private network here. So that private network is using a special IPS, intrusion prevention system here, that exists in between the at exit point and entry point, exit point and entry point. That means you can install or you can configure your router's input port as well as your output port for sensors. Right? So in this network base, the network, it can be implemented using a dedicated or non-dedicated IPS devices, as we say, use these sensors here. So network-based IPS implementation are a critical component of intrusion prevention. So there are host-based IDS and your IPS, but these must be integrated with a network-based IPS implementation to ensure a robust security architecture in this case. So the sensors detect malicious and unauthorized activity in real time and can take action when required. So if you see in this figure, you can find there is one private network and the public network which are there. So here we deployed the sensors are deployed at the designated network points. That is, one is inside the network to protect any of the devices which are inside this network may become malicious sometimes. To protect that one, inside one IPS is used, outside one IPS is used, and if any other server location is there in that network which is connected to the other router, then another sensor point is means every time you're going to have this, means every location in the network, you're going to have a intrusion prevention system. So these IPS systems, they enables the security managers to monitor the network activity while it is occurring, regardless of the location of your attacker's target. So this is something we call based the host based IDPS solution to protect the larger network inside. And another the specialized security appliances will be used, the other type of your security devices. So that we call these are the separate network service, the security providing appliances we call the advanced malware, the protection devices. So they entirely configured to protect any malware type of traffic is getting inside the network or going outside the network will be detected by this AMP. And there is a web security appliances, and third one is your email security appliances are there. So this AMP, the advanced malware protection, is a enterprise class advanced malware analysis and protection solution. It provides the comprehensive malware protection for organization before, during, and after any attack happens inside the enterprise class. So before an attack, the AMP strengthens the defense and protects against known and the emerging threats. And during attack process, during the attack, AMP identifies and blocks policy violation file types and exploit attempts and the malicious files from infiltrating the network. And after an attack, after a file is initially inspected, suppose, and the AMP goes beyond the point in some detection capabilities, and continuously it is going to monitor how to remove that particular file from the attacked folder or from the attacked operating system service, system 32 point folder. So how it will be detected and removed from that. So that is the advanced malware protection part. Whereas your web security, it gives the secure web gateway that combines the leading protection to help organization that address the growing challenges of your security and controlling web traffic. That means nowadays, we are finding that there are many applications, web applications are there. So to identify those web applications, okay, and protect your organization from that, it is, this web security application plays an important role. So while this VSA web security appliances that protects the network from malware intrusion, it does not provide the protection for users who want to connect to the internet directly outside of your protected network, such as your public Wi-Fi services or hotspots, those kind of thing. And another important one is your email security appliances. So in this email security appliances, the Cisco provided this email security appliances for the cloud email security that help the mitigate email-based threats and the ESA defense mission critical email systems. And these email security appliances, they constantly update by the real-time feeds from your Cisco tiles is one. Like that, there are other the appliances are also there. Other company appliances are also there. So which detects and corrects correlates the threats using the worldwide database monitoring system to check whether the traffic is originated from the legitimate user or not. So the basic features of this ESA is the global threat intelligence system is there inside that, so that every time it is going to monitor with any new email threats are identified by any part of the network, and that is updated in the threat system, and that it gives the span blocking and advanced malware protection and outbound message control. So these are the few important features of the email security appliances. So in this spam blocking, the multi-layer defense that combines an outer layer of your filtering. So if any spam is there, that will be separated, that will not enter into your inbox. And it will ask you that whether this mail is trustworthy or not to the host itself. If it is trustworthy, then based on the host request, that mail will be released. So these are some specialized intrusion prevention and detection system which plays an important role in between your network. Okay. One is your IPS and IDS, they both work on the same part. I mean, they use the same technology, that is your signature verification only. but their placement is that takes at the edge router level for entry and exit of your network. What they do means whatever traffic is there, the traffic is analyzed based on the signature. So next we try to talk about the security services. So we have seen the different security devices and where they are going to be placed. Okay. In security devices, first and foremost comes your firewalls. So there are 4 types of firewalls which you have seen. Along with firewalls, other specified devices are also there. We call them IPS and IDS. Where do we place means we place at the network edge level. Firewalls are going to be configured by network administrator, whereas these IPS and IDS are specially designed devices for larger networks. So let us see some of the security services, like how this intrusion detection system works, how the switch port analyze will be done, how the system log will work, how the authentication and authorization will be done. So before going to check that one, let me just play a video for you. Just listen this.
In this example network, security services have been implemented. Let's take a look. First of all, there's an intrusion detection system, or IDS, here. The role of the IDS is to scan packets against security signatures looking for network attacks. This is made possible by the Core 1 switch and SPAN, the switch port analyzer. SPAN allows for port mirroring so that traffic coming in on this interface here is duplicated and sent out of this interface here, allowing for the IDS to run a scan against it. Let's see if we can get this working. I'll send a ping echo request from the Edge 1 router to the syslog server. Notice how the ping or message is duplicated and sent to the IDS as well. The next service we'll take a look at is syslog. We have a syslog server from the Edge 1 router to the syslog server. Notice how the ping or message is duplicated and sent to the IDS as well. That's been implemented over here. The role of the syslog server is to collect log messages from devices on the network. The logs could come from other servers, or they could come from switches or routers, or even end devices can be configured to send log messages to a syslog server. These logs are collected and can be used later for analysis. If we click on the syslog server, you can see under Services syslog, it has received log messages from various devices. Notice 192.168.30.1, 30.5, and 30.3 have all sent syslog messages. Each log message has a timestamp, which is important to track the exact time and day that the log occurred. Another service that's been implemented is AAA. AAA stands for Authentication, Authorization, and Accounting. This AAA server is a radius server that's been configured to handle all user account authentication on the network. The Edge 1 router has been configured to send all login attempts to the radius server for authentication. Let's give it a try. I'll open the AAA server and go to AAA, and you can see there's one account, admin1, with the password Cisco12345. The Edge 1 router has been added to this radius server. You can see the IP address here and the key. Let's add another account. I'll put my name and a password of Cisco, And I'll add that as a user account to the Radius server. And now, if I click on PC10, I'll try to SSH into the Edge 1 router. SSH-L for login, my username Dan, and the IP address. And you can see I'm asked for my password. And I'm in. So AAA services and the Radius server are working. Another useful service that's been implemented in this network is NetFlow. NetFlow is a Cisco service that can be enabled and configured on routers and switches. In this network, the Edge 1 router has NetFlow configured on this interface here for ingress traffic, traffic entering the interface, and egress traffic, traffic leaving the interface. Information in the packet headers, such as IP address, TCP, UDP port numbers, type of service field, and protocol information is sent to NetFlow collector over here. If we open the NetFlow collector and scroll down to NetFlow, you can see that the NetFlow collector is accumulating the different types of traffic and their sources on the network. If we click on this wedge, you can see the source IP address, the destination IP address, and the destination port number is port 22. This was traffic from the SSH into the router. Information like this can be useful to find out who are the biggest talkers on the network and where are the possible sources of congestion. The last service that's been implemented in this network is SNMP, or Simple Network Management Protocol. We have a Simple Network Management Protocol network management station here. The network management station can read information about devices on the network that have been configured as SNMP agents. Not only can the network management station read information about these devices in order to manage them and monitor them, but it can also be configured to write information to these devices as well. The Edge 1 router has been configured to use SNMP, and the network management station can read and write information to this Edge 1 router. Let's give it a try. I'll open up the network management station and click on the MIB browser. I'll need to configure it to talk to the Edge 1 router. So I'll put in the IP address of the Edge 1 router, and I'll click on Advanced. And I'll need to put in the read community string and the write community string because the router has been configured to read information from it and also to write information to it. So I'll put in secret-RO and secret-RW, and version 3 is the version of SNMP, and I'll click OK. Now I can go into the management information-based tree. I'll go to router standard MIBs, and I'll drill down under management, and I'm looking for the system information, and let's see here, system name, and we'll see if we can pull the system name from the router. I'll choose get. Notice there's get bulk, and set. We're not setting information, we're getting information. I'll click go, and you can see the value here, Edge 1. If I wanted to change the name of the router, I could change this to set. I'll put in the name Edge 2 and change the data type from bits to an octet string, and I'll click OK and go, and now the value's been set to Edge 2. I'll change it back to get and click go, and you can see that the value is now Edge 2. Let's take a look at the router and test the name. I'll put in my username, admin1, and the password, and you can see that the name of the router has been changed to Edge 2.
Yeah, so these are the different services to provided in the network. What are those? One is your AAA server, that is authentication, authorization, and accounting availability. Second one is your syslog. Third one is network flow. Fourth one is your SNMP network. So you can see all of these network control services or your security services are connected to your core router, I mean the core switches, the multi switches, and whatever the service, the security services these are providing, they are configured through your edge router itself. So using this AAA service, we can, in upcoming lecture, we are going to talk about that access control list. With this, only the authorized users can send the traffic from the network and receive the traffic from the network is one. So that is what, we have seen, how it is configured by just going. Here you can see, you are saying that at that server, I mean syslog, you are going through a service. You are going through a service. So when you entered into the actual server, the AAA server, you are going through the command line prompt. The command, when you go through command line prompt, there you are going into the system log file. When you go into your system log file, there you will find the services folder. When you enter inside the services folder, there you can start configuring and checking what are the files are received in that network. So when you go through this service, in that service you are entering into syslog folder. Inside the syslog folder, you are going to find the syslog services which are associated with which host, when they logged, their time period, what type of message is there, that the system administrator can check it out easily. And another, we have seen here, the next level of your authentication and authorization. There you are finding in real time when you entered into your authentication and authorization on your system, on your router side or a special device, you will be entered into your operating system. Once you enter into your operating system, there you will go through your command line. Through command line, you have to go to this folder to check it out for authorization and access group. So go through the services. In the services, you will find a configuration file in this folder, that AAA. There you are going to do the operations, that what type of services can be authorized to get into and go outside of your network. Whether you are going to authorize the HTTP service or HTTPS service or both. So in that both, you are going to doing certain management that, by configuring that, whether you are going to allow only HTTP service or HTTPS service, that will be configured inside the index file or in the file management file. So not only this HTTP, HTTPS, what these? These are one of your application layer services, right? Apart from this, you have other services also. What are those? You have the FTP service, TFTP service is there. You are having, some other web application services are also there. So there are a lot of application services, whether you are allowing all those applications to get into or not. Okay. So that is based on that. By configuring that, your next generation firewall, as we talked, it can cover the not only your layer 3 filtering, layer 4 filtering, as well as it can cover all layer 3, 4, 5 and your 7th layer of your OSI model. So in level 3, what it is doing, it is simply filtering based on your IP addresses. At level 4, your layer 4 type, there it is going to analyze your packet based on port numbers. There are some thousands of port numbers are there. We'll discuss about that when it comes to your TCP port numbers. But few port numbers are very important to protect the network, like port number 20, port number 21, port number 22, 23, port number 453, port number 80 for your HTTP. Okay. So these port numbers are minimum requirement. If they are not controlled, any of the attackers, they try to get into your network using these important port numbers. So as a network administrator, when you are configuring, it is very important which service is allowed. For every service, now here we are allowing this HTTP as well as HTTPS. For this port, you are going to allow in the what type of users can allow. In our class, suppose we have 12 members are there. I may give service to only a group of students, like for you two guys, and I just want to block all others. So in this case, in authorization and the authentication, what we are going to do, only your names and key is alerted to you. So you can use your name and password to send this packet or receive those packets, HTTP and HTTPS type. Well, others, they cannot use this email service, the web services. So that's the meaning of, and this is very important to understand here. As we said when we got through this, in authentication and authorization service, it is enabled for certain client names. Now we are having 12 members, right? If we give the client number based on your username, for those client number and what is their IP address. So this is graphically it is showing to you, but on your system, when you are working on your command line, what you will do, you will be at the prompt of your C drive, then your system folder. In that system folder, you will be at the service folder. After service folder, you will be in the AAA folder in your operating system. And that is the path of this. When you are in the AAA folder, there you are going to configuring. You will find a configuration file there. When you open that configuration file, you are the network administrator. You can configure by giving services like HTTP space. You will give -1 and then you will give username. Suppose username is Karna. Suppose Karna. What is his IP address? So and by giving that IP address and give the password for that. So that is the way of protecting that. So client name and their IP address. So then that will comes into a secret, the file, the configuration file. So only they can enter. And for if you have the n number of users, you are going to add other set of users also. So that only those users traffic can go through this edge router, or else the traffic will not go outside the network and they cannot receive the HTTP or HTTPS packets from outside the network to inside the network. So this is the beauty of your what you call the network services. The AAA. This is very, very important to protect any of the users' details. So this is what we have seen, right? Once it is configured here, then they try to connect to or send the packets to verify as a network administrator to check it out whether it is working or not by giving which service is given here, SSH. When configuring the SSH -1 and you are giving the name, client name and client IP address, so then they can access this network. After that, they are going to ask the password which is configured over there. So why this is means by configuring this way, you can protect your network from inside the attacker as well as from outside the attacker. Inside the attacker, sometimes the servers are maintained by your network administrators. We are the client, suppose inside the network. We try sometimes any of the user may try to become a malicious node. I try to attack the servers like payroll system server or like any other security services system like that. So to attack then those servers while going an output line or your outbound line from your router, those ports are blocked. For entire group of clients, only the network administrator can go and access those, these servers. So this we call the privileges configuration on the servers, the router edge part. So everything you can see that. So to achieve all these security services, like only authorized users should access the network, or at what time the users are entered into the network and how much time they use the session, that will be managed by your syslog. And net flow collector is used, means from which device or which user the maximum network traffic is generated inside the network, and maximum network traffic received by the user can easily identify with this network flow collector. And through that network flow collector, one can analyze the network a cybersecurity analyst or network analyst can analyze that what kind of content is going on from that particular user through that network traffic by using your Wireshark, by using Nmap. Those are all comes under your NetFlow collector. Another service is your the SNMP or NMS, the network management. So this is the one of the most important one. So in this network, if you see, every device in this network security service providing devices, they are identified with their own IP addresses. This one is with 251 IP address, this one is 252 IP address, this is 253, and this is 254. So with this, you can identify that there is a separate IP address there, means there is a separate port here at this switch. There is a separate port which all are connected to a single port at your edge router. Single port at your edge router. So the most important portion of network control or network security is the edge router. And second one is whether all the services are clearly examined by the network administrator or not. That is in terms of configuring the layer 3 firewall, layer 4 firewall, layer 5 firewall, as well as your layer 7 application layer firewall. So application layer that covers your HTTP, HTTPS, FTP, Telnet, or other web application services also. Okay. So this is what the basic services which we try to claim. So most of these services will be achieved by configuring the access control list at the edge router. By configuring the access control list at the edge router. So we'll try to discuss this in the next class. But I hope with this you might have added that what is the most important part of your infrastructure, the security infrastructure, that is given idea to. So I think if you are parallelly following this lab execution, then you can understand what is the important of it. I think in the lab part, mostly all these services, your authentication, authorization, and accounting service, AAA service or system log services, you are having the net flow collection, everything will be configured through your terminal itself. You are not going to use any web applications or the software at the host level. We are working at the network-based intrusion prevention and detection system. So we are going to work with the network-based devices, that is your switch level or router level. So in your laboratory, you will see all these, how they are going to be used by following those commands. This is very, very, very important today's lecture. Because the entire network feature depends on today's lecture. Firewalls and IPS. Our entire course is also depends on this one. If we fail here, the objective and output of our course is list. So the video is recorded. I will upload it. Please go through it again and again if you have any doubts. But lab, please complete twice, thrice. It means you practice twice, thrice, and as many times as you practice, that will be a good one. Because most of the marketing, the current market, those who are doing interviews as a cybersecurity analyst, they mainly focus on this topic. So as per my previous semester students' experience, this is very important. So if you are good at this, then your package will be very huge. Your starting package may be like 200K or something like that. Because now there is a huge demand for cybersecurity analysts. It may be for startups or medium scale industries or large scale industries. Yeah, that's all from my side. If you have any questions, you're welcome. Or else, thank you for the day.